All right, ladies and gentlemen, we're finishing up. Basically, this is the very end of Supplement B2. So 1.2 Part 3 is actually Supplement B2. Here's your function. H of x equals 4x divided by x squared minus 25. So it's a rational function. Okay? Rational function means it's the ratio of two polynomial functions, and the one in the denominator has to contain a variable, which it does. Question number 17. Is the point 0, 0 on the graph of h of x? I didn't mean to make one cursive and one printed, but there we go. Same function. Okay, here's how we figure that out. Remember, another name for h of x is really y. You know, no difference, right? So this is really y equals, we have the function y equals 4x over x squared minus 25. If I want to find out if the ordered pair 0, 0 is on the graph, then the ordered pair 0, 0 should be a solution of this equation. So when I plug a 0 in for x and a 0 in for y, the left-hand side should equal the right-hand side. So let's try it. 0 equals 4 times 0 divided by 0 squared minus 25. And if I take it up over here, the left-hand side is 0. On the right-hand side, 4 times 0 is 0. On the bottom, we get a negative 25. But 0 divided by negative 25 is 0. 0 equals 0. Yes. So that does mean the ordered pair 0, 0 is on my graph. All right? Whenever you're given an ordered pair and you want to know if it's on the graph of something, that means you want to know if it's a solution to the equation determined by that function, and yes, it was. Question number 18 asks me for the domain of h of x. Remember, h of x is a rational function. Now, the way I've taught you to find domains of rational functions is what you have to do is look in this denominator and find your restricted values. The best way to find your restricted values here would be to factor first. So we know that x squared minus 25 is the difference of two perfect squares, x plus 5 times x minus 5, and that gives me two restricted values. I know that x cannot equal a negative 5 and x cannot equal a positive 5. Because if either occurred, my denominator would become 0, and dividing by 0 is meaningless. So, what is my domain? My domain would be all real numbers except for, okay, my domain would be all real numbers except for positive and negative 5. Any real number that did not equal positive or negative 5. Now this is how you can write it in set builder notation, but in case you were asked to write it, let's say on a test, in interval notation, the best way to do that is draw a number line. This, of course, is negative infinity. This is positive infinity. Throw out negative 5 by putting a hole there. Throw out positive 5 by putting a hole there. But everything else is included. So if I wrote this in interval notation, it would be in 3 pieces. The domain would be from negative infinity to negative 5, paren, union, negative 5 to 5, that's the middle piece, union, 5 to infinity. And as I've cautioned you in class, don't put brackets on the 5 or negative 5, because if you bracket them, that means you're including them, and you need to remember they're restricted values and they're thrown out. So in this type of problem, when you've thrown out a restricted value, you're never going to bracket it back in when you're writing your answer for the domain. So this is my domain. This is my domain in set builder notation. This is my domain in interval notation. And we're done with those 2 questions. We have 2 more to go.